I'm really excited to um, welcome our speakers. This is really interested to learn about some of these new high performance products, and just appreciative of the opportunity that we have to learn more. Yeah, so thank you both for joining us today. If you would please introduce yourself and um, let us know a little bit about what we're going to learn, and then we look forward to 45 minutes of presentation and then some question and answer. And yeah, thank you both.
Excellent. Well, let me make the introduction. Mary Jo, Robert Masters. We're with 808 Building Supplies here on Maui in Hawaii, and really pleased to introduce Kristen Cora with Climate, who is going to be explaining how the innovative use of these amazing sealants and adhesives can improve the structural integrity of light wood frame buildings in areas such as ours, where we are having high winds, seismic activities, etc. So with no further ado, Kristen.
Thank you so much. Aloha, good morning. Thanks for letting us speak about this innovative chemistry that we hope is going to help mitigate loss and damage from seismic and high wind events. So I'm going to try to share here. Hopefully this works. Can people see my slides?
Yes.
Looks good.
Excellent. So unfortunately, our founder couldn't be here with us today, but he did provide a written transcript that I will, hopefully you'll bear with me and I'll read later when it comes to that section of the presentation. But I represent Climate Adhesives, and we offer a new class of adhesives that hopefully help mitigate, like I said, seismic and violent wind events, which are now ever more frequent and violent and require climate adaptation. So thus the funny title, kind of Climate Adaptation Technology in a Tube, we enable survivable buildings. So we hope that this photograph becomes a thing of the past via innovative chemistry that our founder Phil Jojo has developed over the past 6 years, and really over his whole career has gone into it. So one of the great challenges is violent winds. Business as usual is not sustainable, and adaptation is required. Since we continue to burn fossil fuels and not aggressively enough mitigating greenhouse gas emissions, ecological imbalance is therefore showing itself via more frequent and violent events, by natural disasters, including high wind, which contributed to the disasters in Lahaina last year. Structures are increasingly vulnerable to these events, as said, and they require durable, high performance whole building adhesives and sealants to not only ensure enduring tight envelope integrity, but also climate change adaptation, which delivers structural fortification, protecting lives and property. Sustainable structures are resilient structures. There's a need to update global international building codes to integrate non-toxic, high-performing fortifying solutions which meet or surpass current regulations. And viable solutions require lower barrier of entry because of the urgency at which we're seeing climate change devastate communities globally. This is a wind map of the United States that ironically doesn't include Hawaii, but I found another interesting graphic from NOAA that demonstrates that you're in a interesting part of the world geographically where you have plenty of high wind events, category 3+ that pass nearby within 200 nautical miles, but it looks like they don't hit land very, very often. So I'd love to hear actually from you a little bit more about that later in the presentation or Q&A section. As mentioned, we also mitigate against seismic events. They cause billions of dollars of damage, property damage in the US, an increase significantly since 2017. Over the last year, we heard in the in the news continually about devastating earthquakes all over the globe, including in April in New York City, which is obviously very densely populated and not particularly well outfitted structurally for seismic activity. So not only needs construction of light frame wood and concrete structures be necessary for just normal new projects, but as floodplains, et cetera, due to rising sea levels change, so thus will those new structures need to be amply fortified for the new, unfortunate new norm. Here's a seismic map where it does obviously show the Big Island in red, closest to that fault line. And I thought that these numbers were eye-opening for me as a non-native, that you had that 5.7 magnitude in Pahala in February, and just the sheer number of what is considered an earthquake in the past year. Obviously, not telling you anything you don't know, you are designing and specifying for such for structures to be able to withstand such forces. We're obviously not the first to discover this. United Nations Framework Convention on Climate Change has so much amazing data out, and to this effect, that so much so that they created a loss and damage fund at COP27. It's not also news that those nations that developing nations that contributed least to climate change are bearing an outsized burden from it, just like worst and first a lot of communities in our own country. So that's why we've made not only this novel construction adhesive in itself, but also made it very deliberately financially accessible so that all communities are able to deploy it wherever it's applicable, meaning light frame wood structures, which in Afghanistan and Morocco and Turkey, and a lot of places where they did withstand devastating earthquakes, they don't use stick build very often, but in those areas where it is applicable, we want to make sure that everybody has access to it who could benefit from it. And it's just, we really wanted to include Phil Jojo's story because it really is why the formula is as it is. The reason that it even exists is because he's had his eye on this space for over half a century. So if you wouldn't mind, I'm going to read a narrative from him. In 1970, the American Plywood Association was in the process of developing the first composite structural floor system based on adhesive bonded plywood to floor joist assemblies. To advance the system, they engaged the help of 4 construction adhesive manufacturers to develop a performance test for plywood floors. Mr. Jojo was involved in the test protocol as a product development engineer working for U.S. Plywood Weldwood Division, one of the collaborating firms. The collaboration resulted in the test protocol AFG-01, which you may be familiar with, which demonstrated that a single ply flooring system using adhesives increases the structural integrity of such assemblies by at least 200%. And importantly, I think also for this current adhesive, reduces the span tables for floor joists. Accordingly, I think with the deployment of the resiliency that climate enables, or that this new class of adhesive enables, will start to enable more advanced framing technologies as well, and specifications. The results yield a substantial savings in lumber as well as reduction in the quantity of nails required on a project. The AFG-01 protocol is still used today, importantly. Engineers at APA tried to expand the use of adhesives to walls and rafters with a MOD 24 program, meaning 2 feet off center versus 16 inches. They had good results, but this concept was not well received by spec writers because they could not count nails, but they could count nails rather, but a bonded glue line could not be verified. APA MOD 24 was therefore never implemented. There was also an embrittlement issue with that round of adhesive research, where they made it with urethanes, they made it very durable, but the substrate would fail, and therefore it wasn't adopted. Mr. Jojo's product development career moved forward to weld wood at St. Clair Rubber, to contact Sonobor, and ultimately to Chemlink, the company he founded in 1990, and subsequently is sold to, what's the name of the company? I'm blanking on the company.
Suprema.
Suprema, thank you. The evolution of construction adhesives advanced substantially since 1970. Solvent-based adhesives were often replaced by latex polymer-based products. These then were replaced by moisture-curing urethane. Mr. Jojo pioneered the development of silyl-terminated polyether adhesives and sealants for roofing, waterproofing, and structural bonding. He notes this because it all, as climate does, as this new class of adhesives does, so was this an improvement in health, flammability, and general performance. The ethos of our company, and any company that Mr. Jojo founds, is do no harm. So that's a common thread throughout. Through all these years, Mr. Jojo never lost sight of the potential for bonding panel on frame assemblies through the entire structure of residential wood frame construction. In the last 20 years, the frequency and violence of weather has increased the annual loss of lives and property in the United States. The assumption that nails alone will save lives has failed time after time. Doubling and tripling of nail schedules has proved to be of little value in catastrophic wind and seismic events. Hurricane straps and hold-down devices have only localized value in wind and seismic events. The cost of such hardware and associated labor are significant while offering limited performance value. And conversely, a continuous adhesive bond between all lumber and plywood plus bonded birdmouth joints offer the ultimate structural protection. And the use of adhesives does not violate code in any way. In fact, in the AFG01, that's already code to use adhesives, or floor to subfloor. Testing showed that birdmouth assembly with toenails alone resisted 250 pounds of tensile force. With a hurricane strap, the same assembly yielded 350 pounds. A birdmouth type polymer adhesive and nails reached 1,200 pounds before failure. Fatigue testing also showed that cyclic loading survived much longer with the highly elastic properties of the special formulation. In mechanically attached assemblies, nails and hurricane straps fail early in cyclic loading, and when nails pull out, they never go back in. But a flexible adhesive absorbs energy and returns structural components to its original positions. New polymer technology provides both strength and adhesion with highly elastic properties. Adhesives applied over the exterior lumber surfaces spread the load path laterally across the entire structure and finally dissipates at the sill plate. In pursuit of this architectural concept, Mr. Jojo took 50 years of industrial experience and invested it in formulating an adhesive which can be used to build fully laminated structures that increase the survivability of our homes in adverse wind conditions and seismic events. Because when buildings survive, people survive. So the opportunity that we present is that such built environment damage is now partially or wholly avoidable. Formula is most suitable for light frame wood new construction and concrete. I'll show later when I show our technical data sheet that it adheres very well to several substrates, but we've done the most amount of testing in light frame wood, and therefore that's why we're putting it out to the market as such, because we can stand behind all the data that we've assembled and is published in academic journals. Its high-performance adhesives enable cost savings in lumber, both in the amount and type, labor, and mechanical fasteners with increased performance. So you have a 1/4-inch bond line that is, able to be adhered without skilled labor versus, whatever the configuration is of hurricane straps. Sometimes in Miami-Dade, for example, an entire cable down to the foundation. It's easy to envision the amount of material and labor saved with a 1/4-inch bond of adhesive to the components versus such configurations. And again, as I mentioned, we do have a do no harm ethos of construction supply chain, which we hope will start to be demanded more broadly, including non-toxic adhesives without solvents and HOV off-gassing as this product enables. So we just want to bring to the world the understanding that novel construction adhesives can offer exponentially stronger bonds, as well as being able to handle dynamic load, given its extraordinary ductility. These two factors together save lives and structures, and I'd like to present a video to you of our test findings. Hopefully it works. Every other day, of course, it works perfectly. Here we go. Can you hear it?
While there are many efforts throughout the world dedicated to taming
We can
climate,
hear it okay.
there is
Thank
an
you.
additional action that can be undertaken, one not aimed at managing the weather itself. Instead, this action is aimed at constructing buildings that can survive extreme weather. It's simple, inexpensive, and perhaps best of all, immediate. Better buildings, more survivable buildings, can be constructed with one simple step: the use of a resilient, shock-absorbing adhesive applied to certain areas in wood frame construction. That is what researchers at Western Michigan University's Bronco Construction Research Center in Kalamazoo, Michigan set out to prove. And test results show that the use of specially formulated adhesive in the right places can bring remarkable results. Lead investigator Dr. Bilal Al-Hawamdeh and his team are running a monotonic test on an 8x8 wall. This is one in a series of tests that were conducted to determine the benefits of using an adhesive in light frame wall construction. Previous tests involved walls constructed with 2x4 studs and 3/8 inch plywood sheathing in 3 different configurations: nails only, nails combined with commercially available polyurethane adhesive, and nails with a specially formulated polyether adhesive called Climate. These were tested using a dynamic testing method. As the graph shows, results of dynamic testing on these 3 wall specimens were striking. It required more than 9,000 pounds of force to break the wall assembled with Climate adhesive. The nailed assembly failed at 4,000 pounds. But the story is about more than strength. The ability to absorb energy, to displace it, is critical to a wall surviving the dynamic forces of a hurricane or seismic event. The 3 2x4 walls were also measured for their displacement properties. These hysteresis curves show the lag between the force applied and the wall's response to it. The greater the lag, the better the system's ability to displace force. For the nails-only wall, the loops remain relatively close to the horizontal axis. This is due to nail slippage as force is applied, known as pinching. The specimen consisting of nails and polyurethane adhesive, labeled Adhesive A, shows better displacement than the nails-only wall, and while it is strong, it is also somewhat rigid and limited in its ability to dissipate force, resulting in relatively brittle failure compared to Adhesive B. The large area within the Adhesive B Climate hysteresis curve, with its many high-volume loops, shows an extraordinary energy-absorbing capacity. The test being conducted here in accordance with ASTM E2126 involves a wall constructed with nails and Climate adhesive. The wall specimen, composed of 2-inch by 6-inch studs on 24-inch centers, is a configuration that allows for an increased insulation cavity, thus providing superior R factor. It is also a more efficient use of wood because of the need for fewer studs. This specimen will undergo dynamic forces, or cyclic loading, intended to represent the impact of a high wind event. Previous testing on an identical wall assembled with nails survived only 4,200 pounds, or 4.2 kips.
The purpose of my research was to investigate the effectiveness of the elastomeric adhesive applications into light frame shear wall wood construction. So the purpose was to evaluate the shear strength and the shear stiffness and the ductility of different components when the adhesive are applied into their connections. So the overall goal was to ensure a continuous load path into those structures from the highest points or from the points where the loads are subjected all the way down to the foundation level and into the ground.
The testing machine consists of a top-mounted 20,000-pound double-acting hydraulic actuator, a steel loading beam at the top, which includes a roller system to contain lateral wall movement, a steel base channel, and bolts attached to the shear wall sill plate. Displacement measurements are taken at the top and bottom plates and end studs. Laser sensors are used to record the uplift displacement at the end studs. A special computer program captures the wall specimen's response to stress loads and movement. This is the hysteresis graph, which shows displacement in dynamic push-pull forces. The characteristic bow tie image begins to take shape.
How the nails, how the mechanical fasteners work. Nails are localized spots that can provide some level of friction between the two members. If you have, say, wind load subjected to the top of the roof, the way how it works, the loads will be, by science, needs to move and transfer from that component to the adjacent components. And if you have a gap, or if you have a weak points into that path, transfer path, if you have a continuous load path, the loads can move and transfer all the way through the components down to the foundation. That's the goal.
As the load approaches 14,000 pounds, the climate-bonded wall begins to fail with a sharp crack. Most striking is that failure in the specimen occurs not along any of the bond lines. Instead, as the load path travels uniformly down the wall, the adhesive continues to displace energy until it reaches the foundation. The main wall assembly is completely intact. Failure is concentrated totally within the bottom sill plate with a longitudinal 2 by 6 inch split. This is testament to climate's ability to absorb and dissipate energy away from construction interfaces, functioning like a shock absorber throughout the wall and delivering energy to the foundation.
Climate adhesive, as it has inherent high elongation property and better movements that can reach to 1,000% of elongation. So imagine if we have, as an example, a bond line that has a thickness of a 1/4 inch. This 1/4 inch can be stretched up to 10 times. That will provide that movements that we are really looking at, and that also can increase dramatically the seismic energy dissipation, where we can evaluate the behavior of the structure by how much the structure or the connections or the components can dissipate energy.
WMU testing proves that the use of special adhesive can dramatically increase the structural integrity of light frame wall construction. The adhesive is also applicable to roof rafter construction such as bird mouth joints, which are critical to keeping roof and wall elements firmly attached under violent wind conditions. Bronco Labs continues to explore the benefits of constructing buildings with the use of flexible elastomeric adhesive, which can function as an energy absorber, allowing buildings to survive high wind and seismic events. Of course, we must continue to develop practical issues for managing the climate, but we must also learn to construct more survivable buildings.
Oops. So let me try to present again. Thank you. So the solution that we're offering is on this screen, the primary attribute. So the 250 to 300% increased load capacity versus uniform code nail schedules alone. Without that undue embrittlement, we have the 900 to 1,000% adhesive elongation for ASTM D412 that the professor spoke about. This is really the secret sauce. This is the part that solves that embrittlement issue, gives the durability, but also ability to have all that ductility and take that cyclic load and dissipate it from each of the components down. It distributes it laterally across the wall and distributes it down to the sill plate. Thus, the outer envelope of the structure remains its integrity. It outperforms mechanical straps. The configuration that was tested repeatedly proved 2.5 times in strength. That enables then all those cost reductions. It's durable, it's non-toxic, it's non-shrinking, it's 100% solid, so it's non-shrinking, which is important. It's moisture curing, and you can work with it down to 32 degrees Fahrenheit. It's third-party verified newly via FEMA's P695 certification. That needs to start to get into code, be reflected in code. California Prop 65 regarding carcinogenics, totally non-toxic and without carcinogens, as well as mentioned already, the American Plywood Association's AFG01, which stipulates use in floor to subfloor construction. I also wanted to mention we have a nice article. This is just 2.5 pages in Structure Magazine from last August. If you wanted to check this out, I know it's too small obviously to read here, but it just goes over the video that you just saw, the testing results there as well, in a nice succinct way that's available on our website. And then, as mentioned, the technical performance data sheet information, I redacted our name, even though it was in the video a little bit. Sorry, AIA. Couldn't really get to that editing, but if you want to take a quick look, these are also some of the attributes that are new in at least this formula. Here's all the ASTM aspects that a lot of structural engineers and architects obviously are going to need to understand we were tested against. And then the green standards, hopefully you can see those as well. We're also adding all the time new certifications, including for oxygen aging, which I think only goes up to 50 years, but we understand our product, I'm sure, will last well beyond that, as well as UV testing. Obviously, the non-slump is an internal applications, but we do have a self-leveling that will be exposed to UV potentially. So we're doing some additional testing there as well, which we'll obviously post on our website and in future presentations. We're also doing, well, let me get to it here. The compatible substrates I wanted to also demonstrate, or at least put forward. You'll see stainless steel here. We're doing UL testing, and as in addition to the others that I just mentioned on low slope roof decking, because we know we have good adhesion there. We want to get some hard data behind that as well. So a really good shelf life. You'll notice that it is in sausages instead of cartridges. There's a much higher shelf life accordingly, and much less waste when you use a 20-ounce sausage versus a plastic cartridge. Here are the physical properties. The Shore is 40 for at least the non-slump. The tensile strength, you get that tensile strength even after 24 to 48 hours initial. And fully, it's moisture curing, so it depends on what kind of an atmosphere you're using it. But we tout 7 days you're at almost full PSI and a full cure for sure. 30 days regardless of atmosphere. So we can always go back to this if people have questions. But importantly, where before inspectors can count nails but not see necessarily a bond line, with that 1/4 inch bond line, we do produce ample squeeze out, as you've seen a little bit from the video. And importantly, verify, not only see the squeeze out, but that it's ours, because we have a black light responsive filler that shows that it's this particular adhesive or sealant. So the pathway to this performance is through this new class of adhesive, which allows climate change adaptation, which is just plainly inevitable, unfortunately. We need to help. We're looking for partners and people who are willing to be first. Everybody lines up to be number two, right? With something new in the market space, but the entire built environment ecosystem needs to know about and start to put in specifications that the capability needs to be understood, and the affordability that it enables safer and resilient structures. With the testing data that we've gotten, it lines up with Category 4 hurricanes, F3 tornadoes, or a 5 Richter scale earthquake. So we're ready to deploy at scale. It's made in America, and it's ready currently. So we'd love to explore the power of chemistry over catastrophe with you, where new survivable buildings are the new normal in increasingly vulnerable regions. So I'd love to entertain any questions anybody might have.
I guess you had mentioned the humidity levels. What humidity levels are kind of problematic as far as the shelf life?
Well, if you keep it in a controlled environment, cooler is better. I mean, if you outright refrigerate it, you can get at least 3 years, because just the chemical reaction just stops. So that's the only thing that dictates it. So if you have even a damp surface, you can use the product, and it just enhances and speeds up the reaction once it's deployed.
Great. And then I've got a question regarding the availability, pricing, any information that you could share with us, as well as any of the links to the spec sheets that we can share with our structural guys so we can take a look at it.
Sure. So we do have the technical and safety data sheets. Everything is on our website, including the videos. We have also a series of field application videos that I think are really helpful. They're super short, just to show floor to subfloor, shear wall to stud, and then we're getting one with the bird mouth. And we have the roof panels. Those are available currently. But it's very deliberately kept at a price point commensurate with what's on the market today. It's like $13 a sausage. So obviously, if you become a distributor, demand starts to warrant a distributor relationship, those prices are obviously going to be lower with volume. But a case is of the non-slump, for example, is under $160. That's for 12 sausages. Those are 20-ounce sausages. So each sausage is approximately 48 linear feet. And with Midwestern, albeit these are Midwestern material costs, the National Association of Home Builders puts like a 2,000 square foot structure at approximately $170,000. We come out to less than 1% of those material costs, like 0.88%, to give you 300% resiliency of that outer envelope. It's a no-brainer. We also have a mini skid is 12 cases. That's for $1,722, and a pallet, which is 60 cases, is $6,408. And the masters who are on Robert and Mary Jo, they are available to, and they're helping us, representing us in Hawaii. So they would be able to help with any kind of freight issues whatsoever.
Yeah, David, we've found that on researching this, even if you're bringing in mini skids, that we're price competitive with other popular products. And we're in discussion with AWS, Beacon, etc., about them bringing in full pallets, at which point the per tube price comes down even more and puts us in a really good position price-wise against 1A, M1, and other products like that.
Yeah, so and the presentation failed to describe, because we obviously it's AIA, we try to keep the big capability neutral. But just regarding the different products, we have non-slump, which is for vertical and overhead applications. We have also a self-leveling that's for roofing, for horizontal concrete applications. And then we have the GP general purpose, which is an excellent window and door sealant. So you get that whole building envelope with 3 very simple products. And the
Sure.
GP, by the way, is cheaper even than the other ones, because it's not as, the ductility isn't as high performing as the other 2 necessarily need to be.
SL is running a Shore A40 from a polyether product, which is pretty amazing. So people are excited about that. And the other thing about SL is it can be used in roof penetrations. So if you're trying to deal with situations like that, you can use that material really well.
Does it affect the construction timeline?
I mean, I would think only favorably if you're, well, let's put it this way. You can either replace mechanical fasteners up to code. And as they start to talk about, unfortunately, need for how do we mitigate loss and damage from Category 6 hurricanes? You know, I don't know how much Hawaii is going to be vulnerable to that, but I mentioned that because then you can have climate in addition to mechanical straps as we evolve and need to adapt. Yeah, so it is a non-skilled application of just applying a 1/4 inch bead. If we have time, I do want to share with you. We do have a field application. Oh gosh.
Yeah, if I can jump in while you're looking for that. According to Rob Connell, National Sales Manager, he was estimating that a worker should be able to put somewhere around 700 or so lineal feet of material down per day. And on a 2,000 square foot build, you're looking at somewhere around 4,000 lineal feet of material. So there's going to be somebody sitting there for a few days.
Let me show you really quickly what it looks like as in a field application situation. So that's an example of it being applied in the field for shear walls. It's odd they don't have a fill plate. That's another, that's not our problem, but it's kind of interesting to note. But that structure is now much more resilient than it would have been without it. And we take heart in that. Any other questions at all?
Hi, this is Earl. The question I have is, here in Hawaii, we use lumber and plywood that's treated for termites. And has there been any testing with this adhesive on treated lumber and plywood?
Mm-hmm. I think it's been mostly without treated, but it doesn't, I think the only treatment that we would have, that we would pause is if, and it's probably going to be more so in your area, is for fire retardants, because it would be oily and therefore that would affect the bond. But I think the treated lumber wouldn't necessarily be a problem. We don't have the numbers that we have in untreated, but I talked about this with our founder yesterday for exactly this question that I got at AIA 24. I was just there in DC exhibiting for us. So yeah, we don't have a ton of data with treated lumber, but again, I don't think it would be a problem because it adheres so well to so many different substrates.
Thank you.
So I have a question for you all, if you don't have any more, or even if you do, but just wondering, like, as an architect, or a structural engineer, we understand you're putting your signature on a project and your professional, reputation is on the line. So we are looking, I am very curious about what would help, get over barriers of entry, what would help your comfort level. We've gotten tons of data in, American Society of Civil Engineers, academic journals. But if there's an stamp of approval or a certain certification that you see and readily understand, oh, it's gone through this rigor, what might that be? Because like we said, we are in the climate adaptation business, and people are not, surviving things where they might otherwise. And so there's an urgency to getting deployed.
I would say that, for the most part, I think most of us utilize structural engineers to help us with our actual, construction documents. So I just want to have a discussion with our structural engineer, have them review the data sheets that you have and some of the performance testing. And so long as they're, comfortable with it, then I don't think that there's an issue. I really like the idea. I think it works well with some of the more modular prefab construction that we're kind of looking at for some of the rapid deployment. So yeah, we're really excited about using it. I mean, I know that adhesives are advanced, just in the last 5, 6, 7 years dramatically. So I don't think that there's a question whether or not this technology is applicable or here to stay. So yeah, no, I don't think there's an issue. I don't have an issue with being necessarily comfortable or not comfortable with it. And as long as our structural engineers are happy with the data, then there's no issue, in my opinion.
So I would hope, it's not always the case, but I would hope that it would be performance-based, not prescriptive-based. And people are used to doing what they do, and it's, structural integrity is a big deal. So we just want to be really sensitive to whatever will be helpful, again, getting over those barriers of entry and in adoption.
I was wondering, is it also usable with like the zip system where there's the built-in weather barrier on some of the sheeting?
So I think that would be outside of the stud system, right? So you have the stud to shear wall. That's where the bond line would be.
Oh, okay.
So then anything exterior from that would just be the build outside of the insulation. And we really love that you get that mod 24, you get an increased, so the advanced framing, we're really excited about the increased R factor that advanced framing will allow with this resilience. So, looking at, a 2x8, get an R factor of 30, those kind of things, that kind of stuff is really, really exciting to me, and highly applicable for anybody who's energy efficiency conscious and looking at, passive house certification, that kind of stuff.
Yeah, on that topic, Rob also ran some numbers for us recently, because I was curious about what the numbers may be if you're framing 2x4 at 16 versus 2x6 is on 24. And he ran some numbers on the mainland, and it came back just really swings and roundabouts. The cost was really very favorable in terms of the lumber, but then when you factored in reduced labor costs because you are playing around with less wood, that it actually worked in the favor of going with that system. The one thing he did point out was that some people might have concerns about sheetrock running at 24 on center rather than 16. Some people have problems with it, some people don't. So that was mentioned as part of the conversation.
Is there any
Great.
other part of the, I'm sorry, go ahead.
Well, I was just going to ask if there's any more questions, or yeah, so please go ahead.
Yeah, I was just wondering if they're unfamiliar with the Hawaiian market and the reality of you being architects there. Is there any other part of our system, as simple as it is, that you see as potentially prohibitive that we could try to assuage early on? The sausages versus a cartridge or anything. I mean, it's so simple, but still.
I think for us, it's the thing that we always deal with is shipping costs, right? So just once we understand that and can compare and contrast what those costs would be, I like the idea of the sausage. Is that, and that's just a standard type of application gun, or is that a proprietary gun? I've seen the sausages on other products, but
it's just for 20-ounce sausage. So here's a sausage. You just put it in I don't have a gun with me, but it's just a gun. We ship them out with, if you order a mini skid or higher, we we'll include them. And I should also mention on that line, the only other sort of accoutrement one would need was with the SL. We do recommend a particular primer, but for the NS, you don't need anything else but the gun, and GP as well. And that's all, everything is on our website. But, and for any of you, if there's any further presentations that we could do with your, in conjunction when you are meeting with your structural engineers, we're happy to do that at any time. And you have, Rob and Mary Jo on hand as well in your time zone.
So David, as far as the guns go, we spoke to a few people, AWS and ABC on Oahu. Several other folks have the 20 guns. The popular brand, really nice quality, is made by Albion. And so for the NS, typically a lot of people like to use a 26-to-1 thrust ratio gun. 12-to-1 can also work. If you're going below that, you're pushing it as far as getting a tired wrist by the end of the day. So yeah, the guns are available. It is a standard issue. And the plan is that when people like AWS, Beacon, etc., have these materials on their shelves, that they also have an ample supply of guns, so that contractors who aren't already equipped with them have easy access to them. And yeah, and as far as the pricing goes, I think you're going to be quite pleased with what Climate have managed to do. I've run numbers. I've contacted several shipping companies, Aloha Freight, etc. Run the numbers based upon individual cases, mini skids, and full pallets. And even if you're in a situation where you're just starting out and you just needed a case of something, even factoring in that cost of approximately $100 to ship that case over from the United States, you're still right in there, given the performance and the quantity of material that you're getting. So I think I'll share that information with you as it becomes available, and let you know who's jumped on board as far as local stocking distributors.
Yeah, I mean, this is our founder's legacy project. I mean, he's not in it to make, gobs of money. It's about sharing what he's seen through the industry for half a century and putting that into a very simple tube. It looks very simple, but the formula itself is only born in 2020, whenever it was, 2022, 2023, because it just took that long to have, as David mentioned, the, adhesive vertical itself is advancing really rapidly, and we need it to be deployed so that it spares, structures and lives. So I would just leave it open to please contact me at any time. Look at our website. We're open to partnering for if you have a particular substrate, like Earl mentioned, the treated wood. If there's something really specific to your market that we can test against, certainly we'd love to partner with you. And again, just get over any barriers of entry so that people can start to utilize it.
Yeah, that would be great if you could, take a look at high bore treated 2x and plywood material, because that is a requirement for us, any structural material. So that would be the only specific thing I can think of.
And how is it treated exactly? What's it called?
High bore.
It's called high bore.
Oh, high bore.
Yeah.
Okay.
It's a borate treatment specific for Hawaii for termites and mold mildew. Okay, well, this has been super helpful, and I mean, it's very timely for us because we're now required to perform special inspections for projects that we have in 120-mile-an-hour or higher wind zones, which is quite frequent. Knowing that these types of products can help us ensure the structural integrity is fantastic. So yeah, I just want to thank you all for taking the time to educate us about this, and we look forward to utilizing the products and advancing with you.
Perfect. Thank you so much.
Thanks as all from us for taking the time to listen to us also.
Yep.
Thank you. We're here locally, so we've got supplies, we've got guns, we've got everything, so materials. So if you need us down locally to join you with a meeting with anyone, just give us a call. We'll be there.
That'd be great. And is there a physical location that we can come by and see stuff?
Absolutely, yeah. We're just up here in Kula, so
Okay.
come on up and check out our new Endereed synthetic thatch roof project that we just finished. We're incredibly proud of. Class A fire rated, of course.
Oh, wow.
Yeah, coffee included.
Fantastic. Well, thank you all so much. We really appreciate it.
Thank you too.
Thank you all.
Be well.
Aloha.
Thank you.